Let's talk about operating sets. There are four set operations. As of the moment, we are going to deal with union of sets, intersection of sets, set difference or difference of sets, and set complement or the complement of sets. This practice exercise, the pre-break session for this video, is intended for us to solve these 10 items here with the given sets here. My suggestion is that before we proceed to any of the operations below, we need to make sure that all of our sets are expressed in terms of the roster form. When I say roster form, we need to make sure that the elements are clearly stated per set. The first set here, A, is already in roster form, as well as B, C, and D. That would mean set E is still in its set builder form, and we need to write its roster form. For set E, since it's a set containing X such that X is a vowel, it contains the elements A, E, I, O, U. This is the roster form of set E as all the vowels are placed there. Again, when it's a roster form, you can rewrite it in any way you want, rearrange it as long as none of them are missing or no other letters are placed there. Aside from set E, we also need to consider writing roster form for our universal set here. Why? When you reach number 9 and 10, it's important for us determine first the universal set before operating the 9 and 10. So we are going to write here a universal set, and a universal set is a set containing the letters in the word mathematics. Make sure that there should be no duplication. So the elements here are M, A, T, H, E. No need to repeat M, as well as A, as well as I. At T rather, we have I, C, and an S. Those, and this is actually now your roster form for the universal set for this specific concern. Now that we have this, we can now freely start with the operations at the bottom. Let's start with number one. Number one is the union of set B and set A, or A union B. When we talk about union of sets, we are just going to combine all elements. Say, for example, I have the set of grade 7 diamond students and a set of grade 7 jade students. If I'm going to combine these two sets, I will be including all students in diamond and jade. So in short, I'm just going to combine everything into one set. So if this is the case, for the union of A and B, simply come up with a set in roster form, writing all the elements that can be found in A and in B. A here has the elements M, A, T, and then H. As for set B, you have elements S, E, and then N. Close it, as we are now done writing the elements of set A and set B into just one set. Again, you may rearrange it as if you want, as long as there should be no duplication and none of the items here are missing. That's how union works. Let's proceed to C union D. C union D. Similar with number one, it uses the process or the operation of union. That would mean let us combine elements that can be found in C and ND. That would mean I will be writing here the elements of C, H, A, S, and then together with set D, A, R, T, that's capital letter T, and then I, S, and then close it. Some of you might say that's already your final answer, but we need to make sure that there should be no duplication as the set is defined as a collection of well-defined and unique objects. That being the case, let us try to remove any duplication. I'm talking about element A. We will remove this since we already have A here. So to remove duplication, simply erase it. Similarly, we also have here S as we already have S here. Looking at this, since all elements here are now unique and there is no more duplication, this is now your final answer for the union of C and D. Again, you may rearrange them. We remove those items that are duplicated because that is how sets works. Okay? Now, if I'm going to insert another question here, let's say D union C, will it yield the same result? The answer is yes, because if I'm going to combine the elements of two different groups, no matter which group should I write first, they are just the same. Let's say group of seven emerald students and seven topaz students. If I'm going to list all seven topaz first before emerald, it's just the same if I'm going to write all emeralds students before topaz. And then after it will be topaz. So they're just the same group. So for union of sets, regardless of whether which set is written first, they will yield the same result. Number three and number four are for the operation of intersection. Intersection of sets simply allows us to look at the elements which are common to both sets. In short, that element is found in the first set and also in the other set. If we talk about E intersection D, we are considering the set E here. But again, this set E is not yet in roster form. We have made this, so it is easier for us to look at the roster form and compare it with set D. And look at the common elements. Set E has A as well as set D. That's part of your result. E is not here, so don't write it. I is part of set D, so you need also to write that one. O, not here. U, not here. So we are done with all elements of set E. Let's go to elements of set D. A is yes, written already. R, I, no duplication. T, not there. S, not there. That would mean that for the intersection of set E and set D, we only have two elements, elements A and then I. Considering that same concept, let's follow number four. Number four is the intersection of set A and set B. We are looking at the common elements that can be found in set A and in set B. However, set A has elements M, A, T, and H. But for set B, it has elements S, E, and N. We don't have any common elements between the two. So how do we write our intersection? We write our intersection in a form of an empty set. This means that the answer for the set operation contains no elements as again, there are no common elements. So empty set will do stating that there are no elements in the operation. Or you could also use the operation, the symbol for the null set. So it's possible for us to get a null set or empty set if we are going to talk about the operation of intersection. Let's go to number five, six, seven, and eight. Five, six, seven, and eight is under the operation of set difference. How does set difference works? Imagine an apple or a banana wherein there is a part that is a little bit too ripe or probably rotten. Before you could eat that apple or banana, we try to remove that part, which is again too ripe or rotten, and whatever is left, that is what we are going to eat. Imagine that concept when we talk about set difference. When we talk about set difference, we have here a given set. And then we are going to remove some elements that can be found on the second set. I'm talking about here set D and set E as D minus E. To answer this, let us first write the elements of the first set. That's set D. You have A, R, T, I, and then S. These are the elements for set D. But this is not yet our answer. Our answer here is after we could remove the elements that can be found in set E. Okay? Consider that set E probably the part that is too ripe for a banana or an apple which we are removing. So the elements of set E are A. So A is here. So we are going to remove that. E is not here. Well, we cannot remove that. I is here. Then remove O, U. After enumerating all elements of set E, whatever is left here, this is our result. This is D minus E. What happened to elements E, I, and O? Do we need to write them here? The answer is no. Why? Yes, even if E, O, and U were left for set E, our concerned set is actually D. This is our concerned set. So the elements E, O, and U, which is found in set E, are not our part of the considered set in the first place. So they are not also written in our final result. Let's proceed to C minus A for number 6. C minus A. Again, write the first set being considered. So it has the elements H, A, and then S. This is what is given here. And we are going to remove the elements that can be found and set A. Set A has M, so there's no M here. We cannot remove anything. A is part of set A. Remove that. E and then H. What is left? That is our final answer. Again, what happened to the elements M and then T in the set A? Since it's not part of set C in the first place, we will not write here those elements here. Now there is also a bit tricky when we talk about set difference. What if we're going to interchange them? We have A minus C. Earlier in the union of sets, it doesn't matter which set comes first, they will yield the same result. If I talk about intersection of set, let's say D intersection E, we are still talking about common elements for intersection. So it also doesn't matter which set comes first. However, for set difference, there is a big difference when we are going to interchange sets. Consider this. 5 minus 3 is positive 2. But if we're going to interchange them, let's say 3 minus 5, that's not positive 2. That is negative 2. So the results when the values were interchanged in the process of set difference will not be the same. So similarly, we cannot just say my answer here is set containing S. No, let's try to operate it first. The elements of set A are M, A, T, H. M, A, T, and then H. Close. And then let's remove that what are the elements that can be found in set C. And set C has the elements H, A, and S. So we remove H, A, and then S. But since S is not here, so we will not be writing that. So what is left here are the elements M and then T. What happened to set S, or rather, what happened to the element S? We cannot write it here because in the first place it's not found in set A. Look at the two results. When we interchange them, they are not the same. That is the further proof that when we deal with set difference, we'll have different results. Let's proceed to number 8. Number 8 is B minus A. B is the set containing S, E, and then n. Next is to remove the elements that can be found in A. M, there's no M. A, there's no A. T, there's no T. H, there's no H. That would mean no element will be removed here. The correct answer for number 8 is already this. Do not say empty set. When you say, since no elements can be removed, definitely the answer is empty set. No, we can only get empty set for set difference if all elements can be removed. Consider this: if elements S, E, and N are found in set A, so all of them will be removed, that would be empty set. But then again, since we cannot found these elements in set A, so they cannot be removed and they stay as they are. That is our answer for number 8. Number 9 and number 10 is under the operation of set complement or the complement of a set. This is where our universal set is very much needed. So let me try to copy this and then move here. I'm gonna bring this universal set here. Why? Because if we talk about set complement or the complement of a set, we are going to deal with the elements that are found in the universal set, but not found on a specific set. So if we're going to talk about number 9, a complement, we are talking about the elements that are not found in A, but are found in the universal set. This actually use the process of similar process with set difference as we are removing elements. But we are now not concerned with two different sets, but we are concerned with the given set and the universal set. So to do this, first, let us try to copy here the universal set. Let me copy here the universal set. Okay? So this is our universal set. MATHICS. This is not our answer. This is still the universal set. For A complement, remove those elements that can be found in A, which are M, A, T, and then H. So as we remove them, simply erase. So M, remove them, A, T, and then H. Because these are the elements that can be found on the given set A. Again, look at set A, MATH. So remove the M, A, T, and H. So our answer would just contain the elements E, I, C, and S. Checking, how do we know if our answer is correct or not? Try to combine this complement of A and then A. And if you're going to combine them, they must return to the universal set. Let's proceed to our last item. We have C complement. Similarly, let us copy here the universal set. And then we are going to remove the elements that can be found in set C. And what are those elements? H, A, and S. Again, H, A, and S. So let's remove them. H, A, and then S. What's left? That would be your result. MT, EIC with close parenthesis, with close brace rather. Okay. This is our final answer for number 10. So don't forget these items. When we talk about union, combine everything. Just make sure that you will remove duplicates. Number 2, intersection. Simply look at the common elements. Number 3, set difference. Consider placing first the given the first set, or we call it the minuend set, and then remove what can you found in the second set or the subtrahend set. And finally, for set complement, all items found in the universal set but not in the given set, such as this set A and set C. Hopefully, you've learned something. Thank you and goodbye.